Did we watch the video in here?
No.
No. Sweet.
So was the Otter playing with the rock?
No.
We watched that again.
Great video.
No,
I
this.
saw that.
Oh,
No, yeah,
Okay.
seriously,
Yeah.
we should see that.
Okay, yeah, no, we're actually watching an actual video.
What? That was an actual video, though. Like, it goes on YouTube
No.
and everything.
No. So what did we look at last unit? Oh wow, we don't even know what we just did homework questions on.
The logger?
No, sorry, not last unit, last section. That's my fault.
Like 9.1.
When what were we graphing?
Focus.
Yeah,
The
focus.
directrix.
Parabolas.
Oh yes, thank you, Maddie. Parabolas, right? You guys said all the pieces.
So sorry. Are we gonna be doing
See, this is the danger of recording a first period class, right?
Yeah.
All right. So we graphed parabolas, and we graphed them back in chapter 4. The reason that we're re-examining them and looking at them again
That looks scary.
is this is what we're looking at. This is right from the Moodle page. These are called conic sections. What basically we're looking at now is a cross-section of cones. So imagine in a three-dimensional space, so in our universe, we have these cones. Now imagine that you take a plane, so like a piece of paper, something really, really thin, and you cut it right through the cone. You're going to get different shapes depending on how you cross that cone. So, for example, we've looked at a parabola. That's pretty much where you take that plane and cut it diagonally through. Now imagine you take that plane and you cut it through the cone so that that plane is parallel to the base. You're going to get a circle. Right? So imagine you have an ice cream cone and I don't know, it has a chocolate delicious rim and you stamp it on a piece of paper. You're going to get a circle ring, aren't you?
Or if you just cut it in half and turn it sideways and look at it.
Well, so that would give you that parabola shape, right?
Well, if you did it sideways, yeah.
Right, yeah. Okay, I see what you're
If you
saying.
do it like right in half, it would be a circle.
Yeah, but the nice thing is with the circles, you don't even have to do any cuts because if you look at that base, that also gives you
Oh.
that circle, right? But yeah, if you cut it anywhere such that it's parallel to the base, yeah, you're going to have that circle, but it's going to change inside. Now, if you tilt it ever so slightly, you're going to get an ellipse, which is like an oval, right?
Oh no. Wait,
Mm-hmm.
it's not the rectangle, it's the little circle inside the rectangle.
Correct, yeah, this little rectangle,
That's like the cone.
that's the plane,
Oh, okay, so
right?
that's irrelevant. Oh,
No,
okay,
no.
like when you, it's a thing that's cutting. Oh.
Yeah, right? And then another piece we're going to be looking at is this hyperbola. So it's sort of like a parabola, right? Kind of looks like it, except it's got a twin, so a second piece. And so what we're going to do is we're going to look at each of these section by section. So we looked at parabolas. Today we're going to look at circles, then ellipses, and a hyperbola. Okay. Anybody ever read Flatland or hear of Flatland?
Yeah.
Yeah?
Yeah.
Cool. Do you know what it's about? Or you just...
It's about like if we lived in a two-dimensional world instead of a three-dimensional world, right?
Yeah, that's awesome.
Whoa.
There's a really good book, actually. It's like... It's totally my type of book because it's only about 100 pages. So it's actually a pretty nice little summer read. It's nothing too complicated. But what it's about, it's Flatland. So it's about living in two dimensions. So we perceive three dimensions, right? Up, down, left, right, back and forth, right?
So it would just be
Is there like a plot?
Yeah, it's
Yes,
we
there's
perceive up and down.
So you just be like
side to
really
side.
skinny.
So not only that, but imagine...
We don't perceive.
So imagine for a second... Okay, cool. So imagine you are a shape. So let's say you're a sphere, correct?
Okay, I am this.
So you're like a little soccer ball.
Cool.
Now you enter Flatland. You enter this two-dimensional space. What are you going to look like?
A circle. A
You're gonna-
triangle.
You're going to look like a circle, right? You're a sphere.
Oh, sphere. Sorry, I thought we were a cone.
Okay.
Sorry.
Yes, if you were a
I thought we were
cone.
a cone. Sorry.
But good, if you were a cone,
We'd be a triangle.
you'd be a triangle,
I
right?
had the right idea.
You would be
Right.
kicked a lot.
So what we're doing now, imagine you are a cone and you enter flatland. Depending on which angle we perceive you, you're going to be these different shapes. That's what conic sections are. So there's a lot of sort of geometry in previous topics here. And the reason we're examining this now is because some of you will be going to pre-calculus. And when we go into pre-calculus, you're gonna find out it's more or less a combination.
Oh, that's terrible.
Right? So here's a video representation also on the Moodle of this. So we can see on the left-hand side that we have this plane going through the cone, and on the right-hand side is a two-dimensional representation of what it looks like. And we can see that we get that circle from having the plane parallel to the base.
Is there any sound for this video?
Yeah, maybe. I don't know. It's really boring.
Yeah. The otter playing with a rock.
Okay, we're not watching the otter playing with the rock. Now, imagine I take that plane and I tilt it. Again, I'm going to have this ellipse.
It's off point.
What's that?
It's off. I don't like this. Off.
Now we tilt it even more so that the entire plane is not in the cone, and this is where we get a parabola. So we've already looked at this, but this is what's happening. This is how we get this shape. This is why the directrix and the focus present the shape as it does.
That's crazy.
But now, let's take a look, and this is what's going to happen when we have this angled so steeply that it cuts through the cones twice. That's the hyperbola. So see how it's paired?
Hey, are you doing this or
No, this is a video.
not?
It's controlling.
All right, so again, we're going to look at all these sections piece by piece. Now, the nice thing about today in this current section is that we are looking at circles. I hope that you remember looking at circles from geometry. You're close, right?
Is this with the T like pi r squared?
Close. Pi r squared is what?
That's a
The
sphere.
circle.
That's a sphere.
Is it gonna be what's the other one? Radius.
Pi RH and there's
Area? No, we're not going to be looking at area or circumference, right?
Yes.
We're going to be looking at the equation of this that gives us this circle perimeter. So
A squared.
So again, circumference is this distance. We're not going to be looking at that.
Isn't it just
We want to be looking at this equation that will give us this output.
Have we
Pi r
looked at it? Should I
squared.
know this?
It may look familiar,
Isn't it?
but there is a reason that I am teaching it right now again. So that if you haven't learned it before, you're cool. So, what is this? What did I just draw? You guys are good. What's that distance?
It's
half the diameter.
Is it pi
It's
d?
5. Yes, you are correct. The radius is half of the diameter, which would be 10, but this specific distance, this specific radius, is 5.
Yeah.
Throwing it out there, does anybody know the equation of a circle? And no, it's not pi r squared or 2 pi r. That's the radius and circumference. I'm asking the equation that would give me this circle. It's okay if you don't. Scott?
Y squared equals x squared plus a number.
Not quite. Yeah.
X squared equals YRX.
Not quite. Well, let me give you this.
Something with pi.
What's this?
Radius.
The radius, correct?
Yes.
It's also the radius. Say I don't know what that radius is.
R.
What's the first thing you said?
I said triangle
Why'd you say triangle?
because those are gonna be the same. So that's gonna be the hypotenuses between those 2 points. Like
What's
from,
gonna be the
from
same?
the top of the green dot to the blue on the outside of the circle.
So from like x equals
Like
5.
R and the green line are going to be the same.
So forget the blue line, right?
Yeah.
Yeah, they're going to be the same.
Yeah.
But so here, say I don't know what R is. Ignore the numbers there.
Okay.
Girls. How can I find R?
Find the radius at any other point in the circle. Or
Oh, well,
So again, yeah, I could, but I don't know it at any other point in the circle. How could I find this specific one? Okay, so we're
Triangles, something like triangles.
yes, you're right. Something with triangles. So we're missing the point with that. So look,
Oh, I get it.
hold on. There's the circle, right? Brand new circle. There's no scale. There's no numbers. I have no idea what the values are. There's my radius. How can I figure out what the radius is? Imagine I have a y-axis and your x-axis.
Create a triangle. Yeah.
What's that?
Create a triangle.
How?
From that top dot, bring it across to the Y, or that, yeah.
Oh, then the
Then come
This
there.
will help you.
Yeah.
What type of triangle is that?
Say right side.
Right triangle.
That's a right triangle.
What's this distance?
The same as the other.
No, what's this distance?
Oh, it's radius. I'm just kidding. It's not radius. Okay. Okay.
It's
It's the same as the line.
Okay, what's this distance? We'll come back to that. What's this
It's the
distance?
same distance as the left.
Wait, is that a squared
and b squared?
No, you're getting there. We're getting there,
is that
right?
the one with the roots and all that kind of stuff.
Hold up, guys. You're getting ahead of me. All right. We're in a race, but it's a long distance race. You got to keep pace with me. I'm setting the pace. All I'm asking right now, how do I find out this distance? What?
X1, Y1?
Even more vague than that. More general. Which axis is this on?
The x-axis.
X. So x of 1, right, your starting point is at the origin. So what's the x value there?
0.
So if I want to find the distance between this x of 2 and 0, isn't that just x? And then this would be y.
What's the green line?
It's the time out. Okay, guys. What's the green line in relationship to a circle?
Where's the radius?
Y plus
It's the radius. Yes, it is in fact the hypotenuse of the triangle, and that's going to help us figuring out how we get this formula. But in the circle, it's the radius. If I wanted to find the radius and say I knew x and y, well, is there some theorem I would use, Ashcon? What is Pythagorean Theorem?
a squared plus b squared
A squared plus b squared
equals c squared.
equals c squared. What's c?
The radius.
The radius in this case. And what's a?
X or y.
X or y, and what's b?
X or y.
Right, the other one. X squared plus y squared is equal to r squared.
And that's the formula.
That's the formula for any circle that we can have. Imagine I take that radius and I just swing it around. Right? Anybody in geometry use a compass to draw a circle? Just around, around, around. That's what the equation's doing. It's finding a bunch of right triangles and keeping that hypotenuse constant.
So that's the equation for a circle.
Yes.
The
That's the
area of a
equation.
circle?
No, the circle. So see this line? Right? See the line?
Like just the volume of the
No, 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 no. See the line?
Yeah.
Yeah?
Yeah.
It's called.
That's this equation,
Oh, okay.
right? So just like before, we looked at parabolas. We didn't look at area of parabola. We didn't look at circle, surface area, or circumference of a parabola. We didn't look at any of that stuff because that parabola, that line, is an equation. This circle is an equation. That line is just like any other line we've graphed before, except it just happens to be a circle. So here, what would be the equation of this guy?
Y squared plus x squared equals 49. Oh, sorry. I'm on the bottom one.
This one. Uh-huh.
Draw the triangle.
So this one actually has a scale now.
Okay, so, -4.
All right, well, what's the general formula for every triangle?
Y squared plus a squared plus b squared equals
Alphabetical order.
a squared plus b
No,
squared.
no, no, no.
X squared plus y squared equals
All right.
Circle, circle.
X squared plus y squared equals r squared. Correct?
Yeah.
So, x squared and y squared, like every other equation we've had, we're going to leave x and y as they are. Here, what's the radius of the circle?
5.
5. So what's r squared?
5. 25.
25.
Okay.
So that's all you would have?
That's it. That's the equation of the circle. If I give you that, we can find out what the circle is, and we can draw the circle.
How would you
How are we
figure
gonna
out?
25?
Because the radius is 5. You guys are silly, right? Like, I first show you the circle, and I'm like, all right, imagine there are no values here. And you can't do it. And now I'm like, all right, now we actually have the values, and you guys are all like, but why is it 5? Because you're just being silly. All right, but does this make sense?
Yeah.
Oh, there's a second period.
It's okay. I thought it was Thursday.
Yeah.
That's
I
worse.
thought Monday was Friday.
That's a lot
Wow.
worse.
Yeah, I didn't
So now draw a
And
circle.
then I thought yesterday was Friday also.
Holy crap.
Yeah.
Just, if you just keep hoping it
I just
happens.
keep on thinking it's Friday.
I
Like,
thought yesterday was Thursday.
it's terrible. But
Eventually.
I know today's.
Eventually it will be Friday. All right, so we want to draw this circle. We want to graph this equation. Y squared equals negative x squared plus 49.
So I mean the radius is going to be 7.
We're in a race. You're right, but
Wow.
let's keep pace.
Okay.
All right. What's the general formula of every circle we've looked at?
X squared plus y squared equals y squared.
Yes. X squared plus y squared equals r squared. Does this look like that?
No, you can't.
How
You
can
just
we
have to
make it?
add.
Add the x squared and then
Yeah.
square root.
Yeah, so we can add the x squared to both sides. So I get x squared plus y squared is equal to
7.
We're not.
49,
Well,
right? We only added the x squared to both sides. X squared plus y squared equals 49. So what does r squared equal?
square root.
So r squared equals 49. So what must r equal? 7.
Square.
R squared equals 49. How do I solve for r?
Take square root of 49.
Square root of both sides, so r is equal to...
7.
But wait a minute. Isn't the square root of 49 plus or minus 7?
Yes.
Can't have a negative.
No.
Yes, you can. It's
But
a
you
circle.
Can.
You
It's a circle. They go in different
Can.
places.
No,
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 you can't have a negative value for a line. No, but if you go...
You- So look,
Quiet.
hold up. Dio's right. This radius is a distance. Can you ever have a negative distance?
No, but
Okay,
you
so in this
can-
class, no, you cannot have
but
this
you
negative
can
distance.
Go back
So-
in the negative direction 7
Yeah,
spots,
you can.
which would technically be a negative
No,
distance.
but it's still 7.
Time out, time out, time out, time out.
Would be a point after
Time out,
the 7.
time out, Scott. You are correct, right? However, we're like, as we go around, we're always moving 7 away. It's
Yeah.
like this positive movement.
Yes.
You can't have a negative distance. So just as long as we understand that when we write the radius, it's always going to be a positive number, that's cool. However you want to think about it, because actually in physics, yeah, we do have negative distances and it helps us mathematically. But for us, for this class, we're just dealing with positive distances. So where's the center of this circle?
0, 0.
Yes, 0, 0.
God, that's a terrible circle.
How can I draw the circle?
Go 7 out from 0, 0.
Poor,
I'm sorry.
I know, poor Clayton's just raising his hand. So we can go 7 out from where?
The
origin.
On the axis. On the
0,
axis.
0.
Right. So starting at here, it's going to be easiest if we go out 7 on the axes. Why on the axes? Can't I go out diagonally?
That's just no. You have
But you
to
need the distance formula.
You don't want to do that.
Very good. I could go out diagonally. I can go in any direction. However, I'm going to need to use the distance formula. And, I mean, who wants to do math, right?
Let me think. Not me.
This makes it a lot easier. So now I have to draw a circle that will connect these.
Well, we can't do that. Yeah, technically it could just be a diamond.
What?
Well, that's not where we're
It
talking.
shouldn't just be a diamond. It should
No,
still be a
yeah,
circle.
it could when you think about it, when you draw the lines.
They're
Those-
parabolas.
But look. So they're not parabolas. This, like if I do this, correct? Think about the radius. This distance here is not going to be the same as that distance there. That's why when you have this radius, it goes around to make the circle.
Yeah.
You technically could make it a parabola, correct? Right? Like one of those. Cut them off right at the x-axis. And put an asymptote
But-
right on the x-axis.
I'm gonna be the worst
Alright.
circle drawer.
So look,
It's okay.
personally,
Protracting.
I'm not good at drawing circles either. That's why I cheat. Right? However, if you happen to have a compass, you're welcome to use it. If you do not have a compass, do not feel like you need to go out and buy one. On all your quizzes and tests and, not your homeworks, but anything I have for you, I'm going to give you this graph, right? On your homeworks, do your best. Do it just like we did. Just draw the radius.
Yeah.
As long as you have the correct equation and the radius, these points on the correct spot, correct placement, you're fine, right? I'm not looking for perfectly drawn circles. If it's slightly elliptical, I'm not going to take off points. Right now, all I really am concerned about is, do you understand this formula and can we sketch it? So, here are some questions we can look at. Are these all in the same text
So are
box?
all of these going to have vertexes at 0, 0?
So when we talk about the circle, it doesn't have a vertex, it has a center.
Sorry, center.
center.
Yes.
So,
So
like
what
the
we're-
parabolas, we're still at 0.
What we're going to find is with all those conic sections, we're going to be looking at parabolas, hyperbolas, circles, and ellipses. The circles and ellipses will have the centers at the origin, as will the hyperbola, and the parabola will have its vertex at the origin. For all these sections, the very last section of this unit, so the very last thing we do before we take the test, we're going to take all these formulas that we've been learning and change them ever so slightly so that the vertices and the centers are not at the origin.
No.
It's
Yes.
fine. It's fine. It's not as bad. We're going to have some old friends come back and join our formulas. All right, but right now we're working on these problems. Honestly, the first and the third one are probably the easiest ones, so you might want to try those first. The second one makes you think because you have to get a tangent line. And I know how much you guys love tangent lines. So try these problems out, and then we'll go over them.